Hey guys, welcome back to lesson number 8 in the real numbers course. We've been spending a whole lot of time talking about fractions, and they are important. Hey, wait a minute. You guys remember what are fractions? Fractions are, I need you to yell it out. Yell it out. Fractions are, I can't hear you. Fractions are, I can't hear you. No, I literally can't hear you. I think my volume's turned down. Let me go. Fractions are numbers. Yes, thank you very much. Fractions are numbers. Now, one of the most important things we do with numbers in the real world is we use them to quantify things and then we compare them. And we do it all the time. Like, for example, you see that in things like scores or prices or temperatures, things like that. Like, for example, if you look, there's a basketball scoreboard there. If you look at the scores, Philadelphia had 61, Brooklyn had 63. So we know who won. In this basketball game, 63 is more than 61, so Brooklyn won. Okay? So comparing numbers is really super important. Well, how's it work with fractions? Well, it turns out it can also be pretty clear which one's bigger than another. Let me give you a few examples. Like, for example, if you had to decide which was bigger, 2/9 or 4/5, well, one way we could do it, just to start off, is just to appeal to the number bars. Those have worked really well for us. Okay, so 2/9, there we go, 9 equal pieces, shade in 2. I think you guys are pros at that at this point. And let's do the same for 4/5. There's 4/5, break it up into 5 equal pieces, shade 4 of them, there we go. Now, looking at those bars, it's pretty clear, right? 4/5 is the bigger number. Okay, so the number bars really can help us out at the beginning. How about this? What's bigger, 3/4 or 7/40? All right, well, tell you what, let's do the bars one more time. Let's see how they look. There's 3/4, 4 equal pieces, shade in 3. Now 7/40, of course, we're going to benchmark. So we'll do that quickly. There's 0. All the way down at the end, that's where the 40th piece. Cut in half is 20 pieces. There, that's where 10 pieces would be. Now just a little bit further over to the left, that's where the 7th piece. Oh, hey, maybe we should use that benchmark. That's a good one. Right in the middle, there's where the 5th piece would be. So 7/40 just to the right of that. There's 7. Shade up to there. Wow, man, seeing both of those right next to each other, man, it's so clear that 3/4 is bigger than 7/40. Maybe I could even figure that out before I even went through all the work on the benchmarking there. Well, hold on to that for a second. Yes, of course. The answer to the question is 3/4 is bigger, right? Well, maybe there's something to that about maybe we don't even need to draw the number bars to decide sometimes. Well, like this. How about 2/11 or 5/7? Which of those is bigger? I wonder if we could just kind of, instead of drawing them, just picture the fraction bars in our mind. Like 2/11 and 5/7. Yeah, I can sort of see that. 2/11 is really tiny, but 5/7, okay, that's a lot of the bar. 5/7 is our guy, okay? So that's a good place to get, where you don't even have to draw the bars, but you can just picture them in your head. Think you can get there? Yeah, me too. 5/7 is bigger. Good. Now, we're actually going to give a name to a group of comparisons that we're going to call obvious, okay? Obvious. They're going to be the comparisons that you probably don't even need the bars. All right, we might draw some just to get ourselves settled in this, but these are what we're going to call obvious comparisons. Here we go. Let's take a look. Here's our first group. I'm going to start with some whole number things, but bear with me. What's bigger, $5 or $2? Okay, that's a really obvious question, right? This isn't even fraction stuff. $5 is bigger. What's bigger, 5 feet or 2 feet? Or what's longer, 5 feet or 2 feet? All right, again, super clear. 5 feet is more. How about this? 5/9 or 2/9? All right, well, same thing. 5/9 is more than 2/9. But check this out. 5/9 or 2/9 as a fraction, that's the same thing. 5/9 is more than 2/9. So what's making this so easy, all three of these, or what joins them together, what makes them obvious, maybe not easy, is they're the same things. In the fraction world, that means the denominators are the same. So here's another example. What's bigger, 11/17 or 15/17? Well, 15/17 is more. All right. 8/37 or 7/37? Well, 8 of them is more. Okay. So I think we got our first obvious comparison name. If the fractions have the same denominators, then it's an obvious comparison. You just check out the numerators, see how many you got. Okay? Here's another obvious comparison. What's bigger, 1/4 or 1/7? Now here, hang on one second. I do want to look at the fraction bars here. I think it'll help us understand what's happening here. There's 1/4, 1/7, and there are the bars. Now, looking at those completed fraction bars, okay, obviously 1/4 is bigger. We answered the question. But what's going on here? Why is 1/4 bigger than 1/7? Well, it has to do with the size of the pieces, right? We've got one of each, 4ths and 7ths, and it looks like a 4th is bigger than a 7th. Well, that's because in the fraction world, the more pieces you break the bar up into, the smaller the pieces have to be. Makes sense, right? If you're sharing a candy bar amongst 4 friends, you're going to get a little bit more than if there were 7 friends. Everybody's got to get a smaller piece. Making sense? So be careful with the denominators. I know 7 is bigger than 4, but a 4th is bigger than a 7th. And that's what's going on here. All right? So 1/4 is bigger. Let's compare it with this. What if we had 3/11 versus 3/13? Which is bigger? I want to point out we have 3 of both of the types of pieces, right? 3/11 and 3/13. So what it really comes down to is how big are the pieces? What's the bigger piece? And again, just think back to those fraction bars. 13ths have to be smaller than 11ths. So 3/11 will be the bigger fraction. Sound okay? This is not as obvious, although we're still calling it obvious, as the same denominators. That's like the most obvious. But this one, we're going to categorize as obvious because it means you don't have to do any work. You can just think about it. You don't have to draw any bars. Okay? All right. Let's throw that on our list, I guess. So case 1, it's an obvious comparison, meaning you don't have to do any work. You don't have to draw any bars if you don't want to. If they have the same denominators, that's the best case scenario. Or if they have the same numerators. If the tops are the same, you just need to figure out, well, which piece is the bigger piece. Okay? And we talked about how we do that. All right, I've got one more. What's bigger, 3/8 or 11/20? Now, by the way, notice they don't have the same denominators. They don't have the same numerators. So this isn't an obvious comparison because of case 1. But there is something going on here that's going to be helpful. It's the number 1/2. We're going to use 1/2 as the reference point, okay, as our benchmark. Well, off to the side, if you think about it for a second, in terms of 1/2, 4/8 makes 1/2, right? That's the same as a half. And 10/20 is 1/2. This is just like our last video, right? If you want to compare to a half, you really need to know what 1/2 is. Now, look at our 2 fractions that we're trying to compare. 3/8 is less than 1/2, but 11/20, looking at our box there, 11/20 is more than a half. So 3/8, let me draw something here. We've got 3/8, we've got 1/2, And then we have 11/20ths in order from left to right. They're getting bigger, right? 3/8 is smaller than a half. There's 1/2, just our reference point, our benchmark. And then 11/20ths is more than 1/2. So just between 3/8 and 11/20ths, look who's bigger. The one on the right, when we put them on the number line or we order them, is the bigger fraction. Is that making sense? So sort of figuring out where each one lives relative to 1/2, or which one's bigger, one smaller, we're good to go. Guys, 11/20ths is the bigger. How about this? 7/12 or 49%. Again, if you think about it, when you're talking twelfths, 6/12 is a half. And when you're talking percent or hundredths, 50 hundredths is 1/2. Well, here we go. We're in business. 49% is less than a half, and 7/12 is more than a half. So 7/12 is the bigger number. How's that looking? Awesome. Excellent, excellent job. Let's go ahead and add that to our list. So we really have two broad cases. When is it an obvious comparison and you don't need to draw any bars or really do any work? You just got to be thinking. Case 1, same numerators or same denominators or same numerators. And now if 1 is less than a half and 1 is greater than a half, bigger or smaller, on either side, that's obvious for us. Looking okay? All right, let's put it to work. Let's see if we can use all these things together. Let's see how this is going. All right, let's say you want to put this list of numbers in order from smallest to largest. All right, take a look. Anything that jumps out at you, just yell it out. Oh, okay, you got your hand up? Yeah. No, the guy behind, the one with the shirt, the kid with the shirt. No, the other shirt, to the left. No, my left. Yes, you. Good, nice. Is anyone else seeing that? Did you guys hear that? No? Man, my volume's bad again. All right, let me turn my mic up. All right. He said 0 is the smallest because all the rest of the numbers are something and 0 represents nothing, right? So 0 is the smallest and 1 is the biggest because he sees those fractions there and those fractions are less than 1. All right, so tell you what. I think we can put down then, let's put in 0 in the lowest slot, and then we'll put 1 up there in the highest spot. Sound okay? So let me take 0 and 1 off the board. Now it just comes down to ordering those three fractions. But I want you to notice something. 5/6, is it bigger or smaller than a half? Take a moment to think about it. 5/6, less than a half or greater than a half? Yeah, just yell it out when you're thinking of it. Good. Yes, 5/6 is more than a half, right? Because half, when you're talking 6, is 3/6. So 5/6 is more than a half. And take a look at the other two fractions, 3/7 and 3/8. See if you can convince yourself those are both less than a half. So what I know right now is that 5/6, this one, it needs to go in that spot right there. Since 5/6 is bigger than a half and the other two guys are less than a half, 5/6 is going to be the biggest of those three fractions, right? I'm going to put 5/6 in that slot right there. And now all we need to do, and this is great, is just figure out, well, 3/7 and 3/8, they need to go in those last two boxes, but is it 3/7 and then 3/8 or the other direction? So let's just figure out who's bigger between those two. All right, take a look at them. Is that an obvious comparison? Yeah, they have the same numerators, don't they? So now it just comes down to, well, what about the pieces? Which pieces are we talking about and which piece is bigger than which? All right, we got 7ths and 8ths. So what's bigger, a 7th or an 8th? Good, you guys are remembering. a seventh is a bigger piece than an eighth. So 3 of each of them, doesn't matter. 3/7 is bigger than 3/8. Excellent. Good application. So 3/7 is the bigger of those two, and 3/8 we'll put in the lower slot there. So right in order, 0, then the next biggest number is 3/8. 3/7 is bigger than that. 5/6 is bigger than both of those because 5/6 is bigger than a half, and the other two are less. And then finally 1. Looking okay? All right. It sounded great, what I heard from you once I turned up my speaker. So good work. I think we'll call it a day, and you can get right to work on some problems and working through some more examples. And I'll catch up with you in our next lesson. Take care. Great job.